Since this polynomial is degree 4, we are going to be able to find 4 zeros. Let's use the rational root theorem to find the potential rational zeros, creating fractions of p over q. A reminder is p comes from every factor of the number at the end, so all factors of 6, and q comes from all the factors of that leading coefficient, which is of 7. Here I've systematically listed out all the fractions of p over q, keeping in mind every fraction is both positive and negative. Let's go ahead and simplify those top ones. 1 over 1 is 1, 2 over 1 is 2, and so on. Next, we want to take each one of these numbers, 1, -1, 2, -2, etc., and substitute them into the original function. Once we've substituted them, we find out that the only numbers that make this equal 0 are the numbers 2 and -3. So we've found 2 of our zeros. X minus the 0 of a function is a factor of the original equation. So far, we know that h of x is going to equal x minus 2 multiplied by x minus a -3, but we still need to find that second half. So what we can do is take that original function and divide by the factors that we found so far. What we have left will get us the second half. Let's go ahead and take our original polynomial and divide it by x minus 2. I've set up synthetic division to do that. Let's put 2 there in the front. Okay. Now let's drop it down. So bring down that 7. Then multiply the number 2 off to the side with the 7 to get 14. We can add 5 and 14, make 19. Once again, multiply the number 2 by that 19, we get 38. -45 and 38 equal -7. 2 times -7 is -14. 11 and -14 make -3. 2 times -3 is -6. Add, and of course we get 0. We already knew this was going to fit in. So the polynomial created by dividing by x minus 2 is this one here. Let's come back over to the left to make sure we understand what we've accomplished so far. That h of x, that 7x to the 4th power function, can now be written as x minus 2 multiplied by that cubic that we just found. Now let's divide the cubic by the other 0. So our other 0 was -3. Dividing our cubic by x plus 3 technically. Okay, let's go ahead and move that -3 over. Setting up the synthetic division. Draw a line. Drop it down. So bring down the 7. -3 times 7 is -21. Add 19 and -21, and we get -3. Oh, excuse me, -2. And then -3 times -2, +6. -7 and 6 make -1. Multiply the -3 off to the side with that -1, and we get +3. Adding, we get 0. So when we divide by x plus 3, we end up with the quadratic 7x squared minus 2x minus 1. This further factors h of x, which I've done here on the left. So ultimately, we have h of x broken down into x minus 2 times x minus a -3 times that quadratic. The zeros of the function are the numbers that we can substitute in for x that make this equation equal 0. We already know that if we were to substitute 2 into this equation, that we would end up getting 0, and if we substitute -3, we would get 0. But now we need to figure out the quadratic. So solving the quadratic, I'm just grabbing the quadratic formula and solving. Don't forget, every time you have two of a kind, you get to take a number out. So a pair of twos, take a 2 out. Another pair of twos, take another 2 out. Ultimately, I have 4 square root of 2. That 14 belongs to each one. Simplifying 2 over 14, I get 1/7. And the 4 over 14 is going to be 2 over 7. So here are my other two zeros. I finished answering the question, but just taking that a little bit further, keep in mind I could finish factoring h of x into 4 linear pieces. Breaking that quadratic down, I have x minus each of the other zeros I found.